Welcome back everyone. In this video, we're going to solve this problem on the kinematics of a particle. A particle moves in a straight line such that for a short time, its velocity is defined by this, v equal to 3t squared plus 4t meters per second, where t is in seconds. We have to determine its position, which is the distance of the particle, and the acceleration of the particle when t is 5 seconds. When t is 0, s is 0. Now, the velocity of the particle is defined by v equal to 3t squared plus 4t meters per second. Alright, meters per second. Let's determine the position first, which is also what? Distance. Now, velocity is the rate of change of distance with time. That is ds dt. So I want to say that ds dt, which is velocity, is equal to this 3t squared plus 4t. I'm correct. Since velocity is the rate of change of distance or displacement with time, okay, so I can say v equal to ds dt. So in place of v here, I'm writing ds dt, which is equal to this. Now, ds dt is equal to 3t squared plus 4t. We are looking for s, which is the what? The position or the distance. So we are going to solve this by separation of variables, okay? Variable separable differential equation. So this is a differential equation actually, so let's solve it. ds is, if I cross multiply, 3t squared plus 4t dt. I've separated the variables. ds on one side, dt and t, which is the function of t, on the other side. So I'll now integrate both sides, okay? I'll integrate both sides. So the integral of ds is equal to the integral of what? 3t squared plus 4t dt. The integral of ds is s. Now let's integrate this. Integrate 3t squared with respect to t. That's 3t cubed all over 3. The rule of integration, add 1 to the power and divide by the sum. Plus integrate 4t with respect to t. That's 4t squared all over what? 2. The power of t here is 1, so 1 plus 1 is 2. This is the 2, and then we divide by the 2. So we add a constant to it, the constant of integration. S is equal to 3 cancel 3, alright, 2 here is 1, 2 here is 2. So we have t cubed plus 2t squared plus c. Okay, so let's call this equation 1 for example. We need to determine the value of c here. The question gave an initial condition, t is 0 and x is what? 0. So when t is equal to 0, s is also equal to what? 0. So plug in 0 here. 0 is equal to t cubed, okay, t is 0, so plug in 0 for t, plug in 0 for t here, that's 0, plus c. And this implies that what? C is equal to 0. So the distance, s will now be equal to t cubed plus 2t squared plus 0. And plus 0 is still the same thing. So let's call this one equation 2. So this is the distance equation. Okay, well the question says we should determine the distance when t is equal to what? 5 seconds. So when t is 5 seconds, the distance is this. Let me put it in bracket. This is 5 raised to the power 3 plus 2 into 5 squared meters. 5 raised to the power 3 is 125. 125. 5 squared is 25. 25 times 2 is 50. So add up together to get 175. So the distance is what? 175 meters. So the distance of the particle when t is equal to 5 seconds is 175 meters. Now, what is the acceleration when t is 5 seconds? Acceleration is the rate of change of velocity with time. That is dv dt. So what is the acceleration? Is to differentiate this with respect to time. That is d dt of 3t squared plus 4t. Let's differentiate this now with respect to t. Differentiate 3t squared with respect to t. That is 6t. 2 times 3 is 6. 2 minus 1 is 1. Differentiate this with respect to t, we have 4. So this is the acceleration equation in terms of t. What is the acceleration of the particle when t is 5 seconds? When t is 5, a is equal to what? 6 into 5 plus 4. This is 30 plus 4, 34. So therefore, when t is 5 seconds, the acceleration of the particle is 34 meters per second squared. So this is it for the acceleration of a particle when t is 5 seconds. Alright, keep following, keep supporting by subscribing, like and share this video to your friends and your classmates. I'll see you in the next one.